So now we finally start getting into reactions of organic compounds. And this is largely where we're going to be for the rest of this course, as well as organic 2. And the major piece that we're going to start with today isn't really the reactions of any one given functional group. We'll be looking at a couple reactions in this section, but this is more of a generic overview. And it gets us into what we call reaction mechanisms. So over the course of Organic 1 and 2, we're going to learn a lot of reactions. In fact, we're going to learn over 100 reactions. Now, that's just a small number of the reactions that are available to us in organic chemistry. There are well over 500 reactions that are considered significant or different enough to be given names. And so that number may sound fairly intimidating at first. But what's important here is there's a much smaller number of pathways. So as we start learning the steps that are involved in a lot of organic reactions, we start to see those same types of steps over and over and over again. And that ends up making our lives a lot easier. So what it'll start getting us into, and we'll explain what this means in a few minutes, is what we call reaction mechanisms. And when it comes to reaction mechanisms, there's a much smaller number of choices. And one of the things that I always like to compare this to, every once in a while someone knows what I'm talking about, but I often like to compare organic reactions and mechanisms to something that you might not think of in that way. And that's a type of musical writing style known as theme and variations. It's a technique where, as you can see the definition here, we start with a certain theme and then we repeat it, but we altered it slightly each time. And that's what we see in organic chemistry. There's a smaller number of basic pathways, and then we just keep making slight changes to them. So in a few minutes, I'm going to show you a list of what I consider to be sort of the 13 basic mechanisms that we will see throughout this course. And those 13 basic mechanisms, to me, make up probably better than 90% of the reactions that we will learn in this course. So mechanisms are not easy. They're actually one of the harder things that we do in this course. But as you learn your mechanisms, it makes the other things that we do a lot easier. So I first want to talk about some just general reaction types. Again, these are ways of classifying reactions, of organizing reactions, that's going to make them easier to think about when you are learning specific reactions. So we have what are known as addition reactions. These are exactly what they sound like. It's a combination of two reagents to form a single product. So an example of that would be a reaction like this. Here we start with an alkene and we add water to it. And the result is that the water molecule gets added to the starting material. So we started with two starting materials, and we ended with one product where they were combined. So that's an addition reaction. We also have the opposite of addition, which is known as an elimination. And so this is, to a large extent, the reverse of addition. And here we split a starting material into multiple products. So we take this starting material and we split it up. So the hydrogen and bromine that I've circled will be one product, and we get an alkene as the other product. So in many ways, eliminations are the opposite of what we see with additions. Our third type of reaction is substitution. And this is a switching or replacing of parts. So here the I- is going to replace the bromine. And these types of reactions, substitutions, we'll see them throughout, especially organic 2. Won't see them much in the end of this course, but we'll see a lot of them in organic 2, especially right at the beginning. So the first two reactions that we cover in organic 2 are known as nucleophilic substitution unimolecular and nucleophilic substitution bimolecular. And they are substitution reactions. Our fourth class, sort of generic class of reactions, is probably the least common, but is known as a rearrangement. In a rearrangement, we start with one reactant, we end with one reactant, but it reorganizes itself. So here's our starting material, and this can undergo a rearrangement to form a product that's going to have the same number of carbons, the same number of hydrogens, but we've rearranged how the atoms are put together. Now, for any reactions that you've seen before, with the exception of what you may have done in a kinetics chapter, and that can vary, most of the time you see a reaction, you see some starting material or starting materials react to form certain products. And that's about all you end up saying about the reaction. Yeah. Not a lot else, and don't really get into much in way of the details of the reaction. But when we draw the reactions like this, there's a certain implication that maybe things take place in just a single step. And that's generally not true. And we might have that A and B react to form E and F, which then form G, which forms H and I, which go to the products. So even though the reaction is, drawn starting materials and products, there might be multiple steps in the middle. And hopefully you recall from Gen Chem what you would call each of these. These are known as intermediates. And so if we want to fully describe a reaction, we need to look at what's known as its reaction mechanism. A reaction mechanism is a step-by-step pathway and it shows us everything that happens during a reaction. So how bonds are broken and how they're formed over the course of a reaction, including all of the intermediates. All right, so why do we care? Why do we need to learn about these mechanisms? Well, from one point of view, it's the mechanisms that truly help us to understand what's going on in the reaction. There are cases where we could show 2 or 3 or sometimes even more reactions that will do the same thing. And by the same thing, I mean they convert the same functional group to the same to whatever product. But sometimes they behave very, very differently because their mechanisms are very different. And so the path from getting from that starting material to those products can be very, very different. And so, as I said earlier, well, we're going to learn well over 100 reactions in this course and organic 2. I would say that well over 90% of the reactions fit into 13 major mechanistic categories. Now, that's not to say that every one of these reactions is one of these mechanistic types. We will learn about reactions that might include 2 or 3 of these mechanisms or mechanistic pieces. So I'm just going to give you this list. It's not a list that you need to memorize, and a lot of the terminology on here won't make any sense today. But it's something to keep in mind. That if you know and you understand these 13 basic mechanisms, that you'll be in good shape to learn the mechanism to any reaction. Now, these aren't the only 13 sort of major pieces of mechanisms, but again, they make up the overwhelming majority of what we do in this class. And so you can see we have some of the different types of reactions we talked about above. We have substitution, such as nucleophilic substitutions here, and acyl substitution, alpha substitution, and electrophilic aromatic substitution. We also talked about eliminations, additions, and Diels-Alder probably fits closest to a rearrangement of the group that we've talked about.